be short circuited when the current sources are presenting in the circuit, that can be open circuited. That means our aim is to find this the main circuit. In this circuit, the current flowing to the 10 ohm resistance, is equal to the current flowing to the 10 ohm resistor when we apply the Thevenin's voltage here. By applying the Thevenin's voltage here, that is nothing but a verification of Thevenin's theorem. The circuit diagram for R1 is equal to, according to the circuit diagram, then R1 is equal to 10 ohms and R2 is equal to 15 ohms and R3 is equal to 20 ohms and low resistance RL is nothing but 10 ohms. Our aim is to find the current flowing to the 10 ohm resistor. That is nothing but the connections is given in this circuit. Then we do the calculations. For the given values are 5, 10 and 15 volts. The 5, 10 and 15 volts. 5 and 10, 15 volts. For 5 values, theoretical values is 0.105 for this circuit, and 10 volts 0.210 for theoretical values for the main circuit, and 15 volts 0.315. That is nothing but theoretical values as we done the experiment for this diagram. Then these calculations may be done by using either Kirchhoff current law or Kirchhoff voltage law. Our aim is to find the current flowing to the 10 ohm resistance. According to the practical circuit, this is nothing but RPS. To measure the resistance value, the first resistance value is nothing but a 10 ohm resistor. The second one is nothing but R2 is nothing but 15 ohm resistor. R3 is nothing but 20 ohm resistor, and RL is equal to 10 ohm resistor. According to the circuit diagram, from positive terminal to the 10 ohm resistor, by the connection from positive to the 10 ohm resistor, from 10 ohm other end to the two wires is taken. One is 15 ohms bottom, another is nothing but 20 ohms bottom. Other 15 ohms bottom to the ammeter, ammeter other end to the connected to the 10 ohm. This is a load resistance of 10 ohms bottom. Other end of the 10 ohms is connected to the 20 ohms, and 20 ohms is connected to the negative supply. This is the connections for Thevenin's theorem for main circuit. That is nothing but a primary circuit or main circuit. When the supply is given, then applying the 5 volts, in this diagram, simulation results is given this value. When applying the 5 volts here, by wearing this rheostat, by wearing this RPS 5 volts, then this current is nothing but 0.1. 0.05 into 2, that is nothing but 0.1. Then go for 10 volts. This is nothing but 0.1 into 2, that is nothing but 0.2. Then we go 15 volts. For these three values we verify this Thevenin's theorem, that is 0.15 into 3 is nothing but 0.315. This is nothing but a practical values for the main circuit. The second circuit, we calculate the Thevenin's voltage. By calculating of Thevenin's voltage by removing the load resistance. By removing this load, we connected this voltage. Output terminals, by removing this load, by removing this RL, then connected the voltmeter across this terminal, then we calculate VTH for the same values. We remove this ammeter, also we connected here. This is nothing but VTH. By removing this ammeter and the load, then we place in VTH. For VTH, the same voltage is applied here, 5 volts. For applying the 5 volts, calculate the VTH. The second circuit, this is nothing but for calculation of VTH. For second circuit, for applying the voltages, VTH is equal to 4.71. That is nothing but 2 into 2 multiplied by 2. This is 30 volts is given, 4.17. Then we go for 10 volts. Then VTH value is 9.46. That is nothing but 4 into 2, approximately equal to 9.45. Then go for 15 volts. then 15 volts we go for 14.1, that is then 5.1 into 2, then got approximately equal to 14 point. The same VTH values is applied here. This is a final circuit for verification of Thevenin's theorem. This is a final circuit for verification of Thevenin's theorem. That is nothing but RTH is calculated theoretically. RTH is calculated theoretically. We get this value of RTH 21.606. RTH is calculated theoretically. That is nothing but 21.6. This can be calculated. R1 and R2 which is can be connected in parallel, then connected with 15 ohms in series, then we get RTH, that is across the open circuit terminals. We place here calculated RTH value 21.66 and connect the final circuit, equivalent circuit RTH in series with the VTH. VTH is nothing but RPS. From RPS to the RTH, from RTH to the ammeter to the negative terminal. Then here we are applying only VTH, not RPS supply voltage. Here we are applying the VTH voltage. That is nothing but a Thevenin's voltage. That is nothing but a 4.72. Here applying only Thevenin's voltage, not a RPS voltage. Given voltage 4.72. Then we get that another 0.512, that is equal to 0.11. This practical value is approximately from the table 1 and table 9. From figure 6 and figure 9, both are same values. Then Thevenin's theorem is proved. That is nothing but 0.1 and 0.1. This is a final circuit for Thevenin's theorem. This is nothing but another experiment, that is nothing but a verification of Thevenin's theorem. Okay, thank you.